Welcome to the Explainer. Today we're cutting straight through all the social media noise to look at the actual, hard, technical data behind a really fascinating new release, Baidu's Unlimited OCR. We're talking about a 3 billion parameter model, with just 500 million active parameters during inference, which is kind of wild, that can literally read an entire 40-page PDF document in a single pass. We're going to look past the sensational headlines to see exactly what this means for the future of document AI, letting the data guide us the whole way.
Here's how we're breaking it down today. First up, the viral hype. Second, the real breakthrough. Third, a reality check on the numbers. Fourth, the competitive map. And finally, number 5, when it actually makes sense to self-host.
Okay, let's dive into part 1, the viral hype, fact versus fiction. On June 22, 2026, Baidu open-sourced this model under a super permissive MIT license, and the internet immediately reacted with absolute fireworks. But, as we see all the time in the tech space, the initial noise can easily drown out the actual signal.
If you've been on tech forums recently, you've probably seen this exact quote floating around. China just killed the OCR business. It's catchy, for sure, but these hyper-sensationalized narratives often distract us from what's genuinely impressive about the release. The reality is far more nuanced. We're dealing with an incredibly clever piece of engineering in a relatively small 3 billion parameter model. But did it literally kill an entire multi-billion-dollar industry overnight? Well, no. Let's start by grounding ourselves in reality, because we have to look at the actual numbers. There's this widely circulated claim that Unlimited OCR saw over 1.9 million downloads right out of the gate, but that simply doesn't survive contact with the actual Hugging Face model page. As of late July 2026, the real figure is right around 8,400 downloads for the month. Yes, it's very popular among developers, but a 1.9 million download phenomenon? Not quite.
Moving on to part 2, the real breakthrough, specifically looking at the architectural fix. So, if we strip away the hype, what actually shipped?
Honestly, what Baidu did here is arguably more impressive than just launching some massive, expensive moonshot. They applied a surgical, brilliant architectural fix to an existing open model, DeepSeek OCR. See, the fundamental problem with standard decoder-based OCR models is memory. Normally, as a model reads and outputs text, its memory, the KV cache, grows linearly until it just hits a wall and slows to a crawl. Unlimited OCR swaps those standard attention layers for RSWA, or reference sliding window attention. Think of it like a human copyist who has full view of the physical page, but only keeps the last few sentences they wrote in their active memory. This brilliant mechanism keeps GPU memory completely fixed and latency totally flat, no matter how long the output gets.
To understand why this is a total game changer, think about how we usually process long documents. We split the PDF into individual pages, process them separately, and then try to awkwardly stitch them back together. We call this page-by-page amnesia. Tables that cross over to the next page get completely broken. Cross-references die. The reading order gets scrambled. Unlimited OCR changes all of that by parsing dozens of pages in one true forward pass, all inside a 32K context window. No splitting, no external loops, just flat latency, and the whole document structure stays perfectly intact.
Because of this constant memory architecture, the speed is absolutely phenomenal. We're talking 5,580 tokens per second throughput on the OmniBookbench benchmark. For context, its predecessor, DeepSeek OCR, hit around 4,951. But the real magic here is the endurance. On Baidu's in-house long-horizon tests, this model reads 40-plus pages in a single pass while maintaining an edit distance error rate below 0.11. I mean, that is just stunning consistency for long-form data extraction.
Which brings us to Section 3, a reality check on the numbers, focusing on OmniDoc Bench version 1.5. Let's shift our tone slightly and ground these capabilities with some hard, objective data. If you read the viral posts, they'll tell you Unlimited OCR is the undisputed state-of-the-art. And, well, that's only true if you compare it to a very specific baseline. Overall, on OmniDoc Bench 1.5, the current standard for document parsing, Unlimited OCR scores 93.23. That definitely beats DeepSeek's 87.01. But, and this is a big but, it's actually not the highest-scoring open OCR model out there. Baidu's own smaller Paddle OCR VL 1.5 actually scores a higher 94.50. So what's the honest framing here? Unlimited OCR is willingly trading a point or two of peak single-page accuracy to gain that revolutionary multi-page flat memory architecture. And honestly, for processing long documents, that's absolutely the right trade to make.
All right, Section 4, the competitive map, specialist versus generalist. To really appreciate where this leaves us, we have to zoom out and look at the broader industry landscape.
There is a fascinating dynamic playing out right now between massive, general-purpose models and tiny, hyper-focused specialists. At the top of the OmniDoc bench rankings, you have specialized models with fewer than 4 billion parameters, like GLM OCR and Paddle OCR at less than 1 billion, scoring in the mid-94s. Unlimited OCR is right behind them. Now look further down. Gemini 3 Pro scores 90.33, Qwen 3, which is a massive 235 billion parameter model, scores 89.15. This is literally the ultimate underdog story. Specialized, tiny models running on local hardware are now effectively outrunning the most expensive frontier general models on the planet when it comes to turning documents into Markdown.
Which brings us to the commercial side of the equation, because if you aren't running open source models locally, you're paying for cloud APIs. Take a $30 figure, for instance. As of mid-2026, that is the cost per 1,000 pages for Azure Document Intelligence's custom extraction tier. Even basic plain OCR on cloud platforms starts around $1.50 per 1,000 pages, and only goes up from there. At high enterprise volume, those numbers compound into massive monthly bills.
But you know, the cloud vendors aren't just sleeping on this. Literally, one day after unlimited OCR was released, Mistral shipped Mistral OCR 4. It costs $4 per 1,000 pages for basic extraction, or just $2 if you batch it. It gives you paragraph-level bounding boxes and handles 170 languages. It demonstrates perfectly how commercial vendors are actively and aggressively responding to the open-source threat by driving down the cost of highly structured extraction.
Which leads perfectly into our final part, Section 5, When to Self-Host, the Pragmatic Guide. If you're an enterprise IT decision-maker or a data scientist, how do you actually evaluate when the cost of local electricity beats the cost of cloud APIs?
First off, we have to acknowledge what you're actually buying with cloud APIs. You aren't just buying OCR. You're buying structured JSON extraction, like Azure mapping out a whole invoice schema, or Mistral giving you those precise bounding boxes. Unlimited OCR, it only outputs Markdown. You're also buying SLAs, uptime commitments, and zero-ops maintenance. Plus, if you're feeding the model physically degraded documents, like say a warped, shadowy phone photo of a crumpled receipt, unlimited OCR's accuracy actually drops to the low 70s. Cloud models and some other open models just stay way more robust in those messy real-world scenarios. So the crucial point is this: self-hosting becomes a decisive business advantage rather than just a fun engineering hobby when 3 specific conditions stack up. Number 1, your volume exceeds roughly 100,000 pages a month, which is where API costs start really hurting. Number 2, data sensitivity. If you're under strict privacy rules like DSGVO in Europe, running an MIT-licensed model completely locally means no third-country data transfers and zero compliance headaches. And number 3, your workload requires parsing long document structures, like books, legal contracts, or technical reports, where maintaining context across pages is absolutely vital.
Actually, a quick aside for the developers tuning in. If you're running NVIDIA hardware, the CUDA paths are totally solid. But if you're an Apple Silicon shop, take heed. That magical one-shot multi-page mode depends on a very specific custom Ngram processor. You absolutely must budget evaluation time to verify that this custom behavior survives the port to Llama CPP or MLX on your specific Mac hardware before you commit to building a whole production pipeline around it.
Let's wrap things up and see how all of this builds to a final underlying truth about the industry right now. Unlimited OCR didn't kill the OCR business, but it did solve a massive architectural problem, and then just gave it away for free. The real frontier we're looking at today is free, sub-4 billion parameter specialist models fundamentally challenging the economics of cloud giants. So I'll leave you with this provocative thought to ponder. Is open source moving faster than enterprise software capabilities, or is it actually moving faster than enterprise software pricing? Thanks so much for joining me for this explainer, and I'll catch you on the next one.